Hello, my name is Rajeev, and today we'll be doing a walkthrough of a simple permanent magnet DC motor. As you can see, this motor is constructed using Legos. The three primary components of the motor required to complete this quick craft are a long piece of magnet wire, a strong magnet, the neodymium variety, and a power source, in this case a 9-volt battery. The direction of current in this setup comes out of the positive terminal of the battery and then flows through the armature windings and into the negative terminal of the battery. In this build, our armature coils are wound in the counterclockwise direction. This current sent through the coils, coupled with the magnetic field, produces a Lorentz force and the magnetic flux. We can explore this in future when we look at the circuit diagrams. As you can see, we've stripped away about half the wire on each side of the coil so that the current can only pass through the coil half the time after every rotation, allowing for it to keep spinning in the same direction. This simulates the effect of a commutator on more complex DC machines. Without the commutator, the armature coils would flip back and forth rather than proceeding in a uniform direction. This step is key in your construction of the simple DC motor permanent magnet configuration. Switching the polarity of the voltage source, we can see that the armature coils move in the opposite direction as before. This is due to the fact that because the current switches direction, it induces the Lorentz force and the flux in the opposite manner as the previous example. Now let's look at some circuit diagrams for both of these configurations. As we can see here, the circuit diagram largely confirms what we witnessed with our actual DC motor. Using Ampere's law as well as Bill's law, we are able to determine that the current moves from positive to negative terminal with the flux going out of the page while the force goes into the page. And this is denoted by the notation on the circuit diagram. As we can see with the opposite configuration, the current still flows from positive to negative terminal. However, the directions for the flux as well as the forces are switched. This working again with our magnet and the flux from the magnet lead to the coils to spin in the opposite direction as the configuration earlier. And this can be repeatedly achieved by just switching the terminals on the power source.